Welcome students to the quick solution of All India Caste Test Series Medical 2020 for OIM and carried forward. This is test number 11, code A and B for chemistry, conducted on 14th of March 2021. So let's start with the first question, which is question number 46. Let's read it. I3 plus is isostructural with. Students, for this question, first of all, we have to understand the meaning of isostructural. And for that, we need to know that the species in which the central atom have same hybridization and same number of atoms attached with it will be isostructural. So let's discuss. I3 plus is isostructural with. Let's start with I3 plus. So here I'm writing species and here I'm writing hybridization of central atom. Let's start with the first species, which is I3 plus. Here iodine is surrounded with two another iodine atoms and two lone pairs. So the hybridization of central iodine atom is sp3 and the shape is bent. Moving to next, I3 minus. Here iodine is surrounded with two iodine atoms and three lone pairs. So the hybridization of central iodine atom is sp3d and its shape is linear. Moving to next molecule, which is XeF2. Xe is surrounded with two fluorine atoms and three lone pairs. So the hybridization of xenon is sp3d and the shape is linear. Moving to next, which is H2O. Here oxygen is surrounded with two hydrogen atoms and two lone pairs. So the hybridization of oxygen is sp3 and the shape is bent. Moving to the last molecule, BeCl2. Here beryllium is surrounded with two chlorine atoms and the shape is linear. So students, it is very clear that I3 plus is isostructural with H2O, since both have bent shape and the hybridization of central atom is sp3. That means the correct answer for this question is option number 3. Moving to next question, which is question number 47. The correct order of electron affinity of given elements, that is oxygen, sulfur, fluorine, chlorine, bromine is. Student, first of all, we are given with 5 elements. 3 of these, that is fluorine, chlorine, bromine, belongs to group 17, that is halogens, and 2 elements out of these, that is oxygen and sulfur, belongs to group 16, that is chalcogen family. And student, for this question, we need to know that generally the electron affinity of halogens are more than that of chalcogens, that is group 16 elements. Students, in general, we know that on moving top to bottom in the modern periodic table, the value of electron affinity decreases. But when we talk about chlorine and fluorine, the electron affinity of chlorine is highest among halogens because of lesser repulsion of the incoming electron with the non-bonding electrons as compared to that of fluorine. Similarly, in case of oxygen and sulfur, the electron affinity value of sulfur is more than that of oxygen for the same reason. Therefore, the correct order, here I am writing the correct order of electron affinity for the given elements is highest is for chlorine, then we have fluorine, then we have bromine, followed by group 16 elements, that is sulfur and oxygen. That means it is very clear the correct answer for this question is option number 3. Students, such questions are very important. In this question, we have compared electron affinity of 2 different groups. So be prepared for such questions also in upcoming NEET exam. Moving to the next question, which is question number 48. If the wavelength of the first line of helium ion in Lyman series is x angstrom, then the wavelength of the first line of Li2+, that is lithium ion, in Balmer series will be. Student, first of all, we need to know the formula to calculate wavelength. Here I am writing 1 upon lambda is equals to r z square upon 1 upon n1 square minus 1 upon n2 square. First, we will be talking about Lyman series. First line of helium ion in Lyman series. So, student, 1 upon lambda is equals to r. For helium ion, here I am writing helium ion because we are discussing first about helium ion. For helium ion, the value of Z is 2 since the atomic number is 2. So, Z is equals to R into 2 square multiplied by 1 upon 1 square. Since we are talking about the first line of in Lyman series, so this will be 2 square, which is equals to 1 upon lambda is equals to r into 4 multiplied by 3 by 4. That means lambda is equals to 1 upon 3r, and it is already given that the wavelength is x angstrom. So this is x. So we can calculate the value of r, that is Rydberg constant, which is equals to 1 upon 3x. Now students, we have to calculate the wavelength of the first line of Li2 plus ion in the Balmer series. So let's calculate this. For Li2 plus ion, 1 upon lambda is equals to r into z square. For Li2 plus ion, the value of z is 3. So 3 square multiplied by 1 upon 2 square minus 1 upon 3 square. Since we have to calculate the wavelength of the first line in Balmer series. So let's put the value of r here, 1 upon 3x multiplied by 9 multiplied by 5 upon 36, which is equals to 5 upon 12x. Therefore, we can calculate the value of lambda. Lambda is equals to 12x upon 5 angstrom. That means the correct answer is option number 2. Moving to next question, which is question number 49. Let's read it. Diamagnetic species among the following is. Students, for this question we need to know that the species in which there is unpaired electron present are paramagnetic in nature. On the other hand, the species in which all the electrons are paired are diamagnetic in nature. So for this question, first of all, we'll be writing the molecular orbital configuration, and then we'll be able to analyze whether unpaired electrons are present or not. So let's start with NO. In case of NO, the total number of electrons are 15. So let's write the electronic configuration. Sigma 1s2, then we have sigma star 1s2, then sigma 2s2, then sigma star 2s2, then sigma 2pz2, then pi 2px2, and pi 2py2, then pi star 2px1 and pi star 2py0. Since there is one unpaired electron, that means NO is paramagnetic in nature. Moving to the next species, that is O2. In case of O2, there are 16 electrons. So sigma 1s2, then we have sigma star 1s2, then sigma 2s2, then we have sigma star 2s2, then sigma 2pz2, then we have pi 2px2, then we have pi 2py2, then pi star 2px1 and pi star 2py1. Since there are two unpaired electrons, again O2 is paramagnetic. Moving to next, that is B2. In case of B2, there are 10 electrons. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then we have pi 2px1, pi 2py1. Therefore, in this case, there are two unpaired electrons. That means this is also paramagnetic. Moving to last, that is C2. In this case, there are 12 electrons. So sigma 1s2, sigma star 1s2, Then we have sigma 2s2, sigma star 2s2. Then we have pi 2px2 and pi 2py2. In this case, there is no unpaired electrons. That means C2 is diamagnetic in nature. So the correct answer for this question is option number 4. Moving to next question, which is question number 50. Intramolecular hydrogen bond is present in. Student, for this question we need to know that intramolecular hydrogen bond is formed when hydrogen atom is in between two highly electronegative, that is fluorine, oxygen or nitrogen atoms present within the same molecule. In that case, we call it as intramolecular hydrogen bond. So, among the given options, in case of option number 3, that is orthohydroxybenzaldehyde, there exists intramolecular hydrogen bonding. I'm drawing the structure. This is the hydrogen bond that exists between this oxygen and this hydrogen. So, that means the correct answer for this question is option number 3. Moving to next question, students.